Okay, continuing with 6.1, let's verifying verifying inverse functions. Okay, so let's let f of x be 1 to 1. Then, if it is, we have that the composition f composed with f inverse of x is x. And we have that the composition f inverse composed with f of x is also x. That's how we verify if two functions are inverses of one another. So for example, verify that the following pairs, verify that the following pairs of functions are inverses of one another. Okay, so number one, let's say we have that f of x is equal to quantity x minus 3 squared plus 5, and g of x is equal to the square root of x minus 5, to which I'm then adding 3. Okay, so let's call f of x blue and g of x yellow. And first, let's evaluate f composed with f inverse of x. So we'll do I don't know that it's f inverse. It's g for the moment. So what that means is into the function for f, I'm going to plug in the whole function g of x. So what does f do with each input? Well, it takes the input, in this case, square root of x minus 5, to which I'm adding 3. It subtracts 3. Actually, let me do this in blue. And then it squares that amount and then adds 5. So I've replaced just the x in f of x with the whole function g of x. So notice that plus 3 and minus 3 go away. So what I'm left with then is the square root of x plus 5 x minus 5 quantity squared. Then on the outside I have plus 5. So the square root is undone by the square. So we have x minus 5 plus 5. So we see that the 5's sum to 0. And we're left with x check mark. So it works going forward. But now I also have to check that g composed with f of x is also x. Once I do that, then I will know, actually let me write this down, that these are indeed inverse functions of one another. Okay, so in this case, I want g composed with f of x. So what that means is into the function g, I'm going to plug the entire function f of x. Okay, so what was f of x? Actually, I probably should have done that extra step. Let me do that extra step here, since I didn't write it. The extra step is to illustrate what's really going on. So into the function f up here, I was plugging the whole function, the square root of x minus 5 plus 3, because that's what j of x is. So let me write that extra step down here too. So into the function g now, I want to plug in the whole function f of x. So what is f of x? It is quantity x minus 3 squared plus 5. So it's quantity x minus 3 squared plus 5. Now that is my input into the function g. So g takes the input, subtracts 5, takes the square root of that, and adds 3. Okay? So it's going to take the input, x minus 3 squared plus 5. It's going to subtract 5 from that, take the square root, and then add 3, right? Is that what g of x does? Yes. Okay, so notice underneath the root, 5 minus 5 reduces. So I'm left with the square root of quantity x minus 3 squared, to which I'm then adding 3. But if I square root or vice versa, I just get what's inside. So this becomes x minus 3 plus 3. So the 3's sum to 0 and I get x, so check mark. So therefore, what can I state? So therefore, where was I? G of x is actually, G was yellow. G of x is actually f inverse of x, and vice versa. So they are inverses of one another. Okay, so let's do another one. Number 2. So let's say we have that f of x is equal to 1 over, x minus 5, to which I'm adding 1. Let's say that g of x is equal to 1 over x minus 1, to which I'm adding, x minus 1, to which I'm adding 5. So once again, I'll call f of x blue, and I will call g of x yellow. And I first want to evaluate f composed with g of x. So f composed with g of x means into the function for f, I'm plugging the whole function g of x. So that is into the function for f. I'm plugging in all of 1 over x minus 1 plus 5. Okay, so what does f do with each input? It does 1 over the input minus 5 and then adds 1. Okay, so f does 1 over the input, which in this case is 1 over x minus 1 plus 5, and then it subtracts 5 in the denominator, and then it adds 1. That's what f of x does. Okay, so of course, plus 5 minus 5 sums to 0. So I end up with 1 over 1 over x minus 1 plus 1. So what's going on there? That means I invert and multiply. So this just becomes x minus 1 over 1 times 1. That is x minus 1, to which I'm adding 1, plus 1 minus 1, and I am left with x. That's a good thing, check mark. But now I have to go backwards. So now I need to evaluate g composed with f of x, and hopefully also get x. So g composed with f of x means into the function g, I'm plugging the whole function f of x. So into the function g, what is the function f of x? I'm plugging in 1 over x minus 5, 1 over x minus 5 plus 1. Okay, so what does g do with each input? Does 1 over input minus 1 plus 5. Okay, So it's 1 over input 1 over x minus 5 plus 1 minus 1, and then plus 5. Okay, so we see that the ones reduce or sum to 0. So I'm left with 1 over, so give myself a bit more room, 1 over x minus 5, to which I'm adding 5 on the outside. So invert and multiply. This becomes x minus 5 over 1 times 1, or simply x minus 5 plus 5. 5 sum to 0, and I get x check mark. So therefore they are inverse functions.